Right. Can you all hear me? Okay. So when we think of ionic, we think of metal with a non-metal. Remember, opposites attract, right? So ionic compound is when you have a metal, and typically your metals are what charges? They're positive charges, right? And your nonmetals are typically what charge? Negative, right? So let's do some examples. Let's say on the test you get sodium bromide. Right? The first thing that you always want to do is identify what you're given. Obviously, we know that this is an ionic compound, right? Because sodium is a what? It's a metal. And we know that it's a what charge? If we look at our periodic table, it's in group 1, and those are +1 charges, right? So I'll write it in red. So we know that Na is a +1 charge. And remember, we can just annotate it with a plus sign. Bromine, on the other hand, is this a nonmetal or a metal? It's a nonmetal. What charge does bromine have? A negative, right? So the way that we write that is Br negative. So remember, what is the goal when it comes to ionic compounds? Right, you want to make sure that they're neutralized, right? So again, the fact that we have a +1 with our sodium and the fact that we have a -1 with our bromide, 1 + 1, yes. Oh, sorry. So I just wrote +1 and -1. There we go. So +1 take away 1 gives you what? A 0, right? So everything is neutralized, everything is balanced out. So therefore, our chemical formula for this one checks out, right? NaBr. What would be the name? Let's say you're giving the chemical formula on the test. How would you name this? Sodium bromide. How come it doesn't have a Roman numeral? Right, it's not a transitional metals. Transitional metals are the only ones who have Roman numerals. And what do the Roman numeral usually tells you? What does that tell you? Right, it tells you the charge of that particular transitional metal, right? Let's say you have chromium 2 chloride. All right, let's first identify what we're working with. Chromium is a metal, non-metal. What is this? It's a transitional metal. So therefore, is the periodic table going to tell us what charge it is? No. How do we know the charge of this one? Right, because of the Roman numeral. So in this case, this chromium, what was that? Oh, in this case, this chromium is a what charge? It's a 2+, right? Because that Roman numeral tells us there. Chloride, for sure, we know it's a nonmetal or a metal? It's a nonmetal, right? And we know for sure it's what charge? It's a negative charge. So here, what do we have to do in order to balance it out? So how do we know it's negative? Remember on your periodic table, right? Chloride is in that 17th group. It only needs one more electron to be like a noble gas, right? So therefore, it's going to take that negative charge. Okay? So a trick would be, you would just multiply the numbers, right? You have 2 here, so 2 times, and here you have what? 1, and you get a total of 2, okay? Therefore, on your chromium, which is a metal, It's a plus charge. We want to add it up to +2. And our chlorine, because it's that negative charge, we want to add it up to -2. Chromium it's already added to +2, right? And we're looking at the charges here. But chlorine is not. We only have one chlorine. How many more chlorines do we need in order, right? We need one more chlorine in order to add up to that -2, like that. So now our chemical formula, you never want to write the ion. You will get that incorrect. You always just want to write how many ions you used to balance that out. So we always start by writing our metal first. In this case, it's chromium. So Cr, and how many do we have here? We just have one of those ions, right? So we don't really have to write a subscript of 1 because it's already intended that there's one chromium. Chlorines, how many chlorines do we have? We have 2. 1, 2, right? 2 and then 1. And that's it. Any questions so far? Okay. Let's do another one. What was that? Right, you want to make sure they cancel off. You want to neutralize that compound. Okay. All right. So you guys walk me through this one. So copper 3 hypoarsenite. Recording in progress. So what do I do first?
Well, copper is gonna have 3 plus, so it's gonna be C with the 3 on top of it.
And how do we know that? Why does copper have a 3 plus? Because of the Roman numeral, right? So Cu 3 plus. Okay, what else?
And then it's gonna be the next one, which is I'm not too sure.
Hypo, that's when they don't have oxygen, right?
Yeah.
Was that Jordy?
It's like, because I know like hypoarsenite, and they're already missing, when it's already ICU, they're already missing one. Hyper is missing an extra one.
Okay, that's right. But there's oxygen there, right?
Yeah.
Okay. So what does that look like? What is the formula for hypoarsenite?
AS, and then oxygen, just one oxygen, I believe. AS, and one oxygen.
So like this?
Yeah.
Do you put money on it? Are you gonna put money on it? Are you confident?
And then isn't like one negative electron or one electron, isn't it?
All right. So like this. What about Kalinga or Fireball? What do y'all think?
You guys agree with them?
So is it ASO3 or ASO? And how do we know that?
Are you sure? You want to put money on it?
ASO?
You're gonna give me $5?
If the first one is wrong,
Okay. Are you ready to pay me $5? I have cash up right now. So.
I feel confident in my peers that he's right.
Okay, I'm glad you do. So.
Don't say that. Don't say that. You're just putting it on me.
Okay, so look on your polyatomic table. Is there arsenate on there? So what does arsenate look like? Is it O3? ASO4.
So then remember the stairs.
Hold your horses. Come on, relax. Okay, so we know that arsenate, N-A-T, right? N-A-T-E, right? So it had 4 oxygens. Then arsenite should have how many? 3 oxygens. Then hypoarsenite should have how many? 2, right? Give me my $5. I have to look what it is. I don't know what it is. we'll save it. We'll have an ongoing bet going on. You know? So by the end of the semester, I should have about $100 in my, you know.
So AS.
Okay, questions, concerns, cash. Okay, so are we done? Is that it?
Now we gotta even it up.
We got to even it up because we know it's an ionic compound and they have to balance each other out, right? So, are they balanced? Okay, so then what should be the final answer? Should there be charges on it? Should there be charges on it?
No.
No, the final answer should not have charges on it. If it does, it's wrong, right?
Oh, 'cause oxygen has.
So you're focusing on the charges. So Cu, we always want to put our positive charge first, Cu.
No, it makes it, yeah, sort of
So
like a
you
noble
said
gas. It
Cu
makes it balanced.
parentheses.
It makes it
So are the parentheses needed? Because how many of those ions do you have? Just one. So do you really need to add the parentheses? No.
Okay, are you guys feeling confident in this, right? Because you guys, you know you have a test this Friday. Guess what it's going to be on? It's going to be on nomenclature, right? So you guys have it down. You got it. You know, I can name any chemical. I went to the, you know, the aisle, the store the other day, and I was going through. I'm like, oh, yeah, I can name that one. I can name that one. I can name that one. You guys can do that, right?
I don't know how to make it go very but that's what the thing is for the periodic table.
Yeah, the periodic table helps you out, and the polyatomic ion table helps you out. Yes, ma'am.
Yeah, we see it.
Okay, good. So you guys can help me start out. So if I have one carbon, I use what abbreviation? Or prefix? Meth. If I have two carbons, eth. Oops. If I have three carbons, can you fix that one? That one. It doesn't work? Okay. Prop. Okay, 4 carbons. Tetra. No, tetra is for Greek prefixes. Butyl, butte, because I'm so beautiful. Okay, 5 carbons. Penta, okay. 6 was hexa. 7. 8. Octa. 9 is nona. 10. 11. 12. 13. Tridec. Okay, so at this point, we talked about priority. So alcohols were the highest priority. Who was underneath them? Amines, okay. So underneath them, alkenes. And then alkynes, then alkanes, haloalkanes. Okay. Okay, we talked about some prefixes. So what is the prefix for alcohols? Not suffixes, prefixes. No. I'll remind you, hydroxy. And the suffix for it is all. OL, that's right. So prefix, it means that if there's something that has a higher priority and it's with something with a higher priority, you use the prefix instead of the suffix. Suffix is like the last name. Yeah, kind of like the beginning. So it'll be in the beginning of it. No, the OL is at the end. So that's a suffix. Okay, so like for instance, how many of you guys have dads, and you have your dad's last name? Well, no, some of you guys may not have dads. I mean, let's be realistic. It's 2021. Not everybody has a dad, you know? Okay, but how many of you guys have your dad's last name? Okay, so it's your dad's last name. Now, I know that in Latino culture, right, you also sometimes have your mom's last name, right? And you hyphenate it. Who goes at the end, dad or mom? Okay, wait. So half of you guys go mom and half of you guys go dad? Well, we got a heated conversation here, don't we? Okay, so that's interesting. So if you are typically from a patriarchal culture, you always put the dad's last name last, right? And if you're a matriarchal culture, you put your mom's last name last, right? Okay, so, you know, the person with the last name is the most important. Patriarchal, last name is that way. So that's the same thing with organic chemistry. The guy that is the most important, you give them the last name, right? So if alcohol is most important, we're going to end it with OL, right? It's going to be ethanol, right? Or it's going to be octanol, you know? So we know that OL represents the most important moiety on there, the most important functional group, okay? Are you guys with me? Okay, so that's priority, right? I got priority because I'm Dr. Henry. You know, Johnny has less priority because he's Johnny, right? Okay, so you guys understand that, right? Okay, so let's see how well you guys understand this. Okay, here is my organic compound. What is its name? Take a moment, you guys can discuss it among yourselves, and then I want somebody to give me a really accurate answer. Okay, so let's start off. What is the first thing that I'm going to do? What am I trying to do first? Find the longest carbon chain. Okay, am I going to start from the left side or the right side? Why am I going to start from the left? What was that? Say it again. Don't be shy. Don't be shy. Come on. That's it. That's right. We're going to start from the right because OH has priority, right? Remember, it's all about priority. Okay. So that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, That's 9. Yeah. Well, it's longer, right? If I went this way, that would be 7 and 8. Wouldn't that be the longest chain? Okay. So the end of it is going to be what? So far. Known. Okay. But we have an E and E. That's right. So E and E. Where's that E and E located at? 6. Okay. So we go 6. And then you said OL. Oops. Sorry. Okay, and it's located, where's that OL at? Double bond is the E, right? E and E, right? That's how we represent a double bond. But, good point. Yes, it's actually located at 5. Good job. Correction. 5. Because it starts at the 5. Okay, what else do we have? All right, 3 bonds? You mean 3 carbons? Is that 2 carbons? 1, 2? That's 2 carbons. So what is a 2 carbon? Ethyl? Where's that ethyl located at? So 6 ethyl. Okay, is that all? What's on that 5 carbon? What is Br? Bromine, so I would call it gonna call it what? What? Bromo. Bromo, that's right. Because we have a bromine on the 5 carbon, right? Hanging off the 5 carbon. So it's a halogen. Halogen is group 17. Those guys, you get rid of the ending, that I-N-E, you erase that part and you put an O. So bromo. So where's that bromo located at? 5 bromo. 5 bromo, 6 ethyl, 3 nona, 5 enol.
Dr. Henry, how did you get the E and R?
Because we have a double
5.
bond. We have a double bond between the 5 and the 6 carbon, right? So that we put the E in, and we're telling it it's at 5 carbon. This guy, it's going to refer to the last name, that 3, or you can just stuck it in here. That's right. Yep, the 3 is saying where the alcohol is at. Yep. That's right, because it's the last name and the number that's in front of that first name, you know, that the nona, that refers to that last one. Okay. Or you could put it directly in front of it as well, too. So you could do it like this. Yeah, I could put the 3 here, or I could put it inside the name itself, which looks nasty to me. But it works. So both of these would be acceptable answers. Okay, questions, concerns? It's because of the double bond. That's right, because we have a double bond between the 5 and the 6 right here. Yes, because the double bond has lower priority Yeah, so normally you would have the nonene if there wasn't the other stuff, right? Exactly. The OH takes priority, yes. That's right. It's just the prefix in that case. So if you guys look, alphabetical. Yeah, yeah. The N is in front of, the N is because it's part of the main chain. Yes. That's right. Yeah, so if it's not part of the main chain, it's going to be a prefix. It's going to be independent of that. Okay, if it's a branch. Yeah, so the question was, let me repeat the question for the class on the other side. So the question was, if it's alphabetical, why am I putting the EN inside the name? And the reason why we put the EN inside the name is because the EN is part of the main chain. The other ones are part of branches. Are you guys with me? Are you with me? Okay, so you guys ready to move on? No.
Can we like do another one? Because I'm kind of like confused, because when you put that NEOL, now is that referring to the alcohol?
No, the alcohol is referring to both the alcohol and the double bond. So let me show you. I'm gonna
Oh, so you combine, okay, I think I know what you kind of did. You just put it all together instead of separating it.
That's right, because the alcohol has priority. So that's going to be part of your main chain, right?
Right.
So that's going to be that's going to be that last name that you're going to give. And then you have the double bond here, right? The double bond is part of the main chain. So you have to include, let me know that there's a double bond. You have to tell me where that double bond is at. So do you guys understand? So the thing about organic chemistry, right? It's not, you notice it's not binary, right? Like what we're doing with inorganic chemistry. Inorganic chemistry was really binary, right? You had two things. You had the metal and the non-metal, or, you know, so it was always really simple and binary. Well, with organic chemistry, you could have long chains. So you have to tell me where everything is, right? So that we can get all of those structures in there. And you always want to end with what is priority. We know that the alcohol has priority in this case. It's higher than the others. So we want to end with the all in that case. But the double bond is also in the main case. So we also want to take that into consideration when we're putting it in there as well. We could have taken the double bond out and put it in front of, right? But it makes it a lot harder to visualize. No, you do put the numbers. Yeah. The numbers are essential, because otherwise, how do I know where things are at? It's 3 because, yeah, it's the main chain, but you're making this 3 make reference to the alcohol, right? Since it's in front of the nona, it tells me where that alcohol is at. The 5 here is for the double bond. Yes. Yes. So the question was, so the numbers here, they tell you what is coming off the main chain, right? So on the 6 carbon, we have an ethyl group coming off, 2 carbons, right? So on the 6 carbon, 1, 2 coming off of that 6 carbon. On the 5 carbon, we have a bromine, because it's bromo. That's how we name it. We don't put the whole thing down there, right? So we cut off that INE and we put O to make it easier. Because otherwise our names are going to be, I mean, don't get me wrong, the names are going to be long. Have you guys looked at the back of a shampoo bottle? Look at some of the names on the back of a shampoo bottle, right? So could you imagine if we spelled everything out? We said bromine, and we'd be there for days, right? Okay, questions? Any other questions? Concerns? Yes, we can. We're going to do one more example like this. Okay. Yeah, yes, ma'am, you will. Do you want me to open it back up? So it was a discussion about, say my name, it's about nomenclature. What are the rules of nomenclature, right? So you guys you've been talking about nomenclature for about a week, 2 weeks almost. We're in our second week of nomenclature. We've been talking about it. Really, we've been talking about it from the beginning, but really 2 weeks, the last 2 weeks we've been talking about it. So you guys at this point should know how to do nomenclature like the back of your hand without any problems, right? That's being able to give me the chemical formula, and from the chemical formula, give me the name. That's nomenclature. Okay, so help me out here. Where are we gonna start from? From right to left. Did I miss one? That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9, that's 10. Okay, so help me out here. So it's 10. So deca. Deca. All I got is deca. Where's the YN at? It's going to be at the 8. What was that? 2 4s? Oh yeah, there's going to be, yes. So how do we say that? We'll get there. We'll get there. So we have Y8, YN. Okay, yeah, we could have a 2 in front of the deca. OL, okay. Four, di. Four, di, what? Chloro. And then what's coming off of that 5th carbon? 1, 2, 3. So 5 propyl. Okay. It's a beautiful empty board. It's really hard. Isn't it really hard to write with the cap on? Oh, okay.
Dr. Henry, I have a question.
Yes, ma'am.
Okay, so from the 2 all the way down, can you like explain that? Because I'm like really lost. I don't understand. After that, once it start getting
This
to
part
like
here?
yeah, all that, yeah.
Okay, so first off, we had to determine the longest chain. What was the longest chain?
10.
10. So that's where the deca comes from. Okay, so the 8, that tells me where that triple bond is. Right? So triple bond, the prefix for a triple bond is YN. So we put 8 YN. The 2 refers to the OL. Because it's in front of the deca, it tells me on that main chain, I have a alcohol group. I have a hydroxyl group or hydroxy group. Okay. So that's where that OL comes from.
Yeah,
Does that
but
make
why
sense?
isn't it by the 2? Why do you have it like by
In
where the
front?
8 is at?
So because it refers to the deca, you could do it that way, or you could put it directly next to the OL. Either way would be okay. Because it's right in front of the deca, it makes reference to that last name. It tells you what that last name is. So like, for instance, if I had, so this guy actually, okay. So if I had this guy, what would I name this guy?
So,
1, 2, 3, 4, 5, 6, 7, 8.
right, there's 8, and then 1, 2, 3, 4. The OH, the alcohol is on 8, 4.
So you said it would be 4 octa.
Yeah, 4 octa.
Okay, 4 octa all, right? Yeah. 1, 2, 3, 4.
Okay, so can you go over the whole last name thing again? Okay, so I get the number of the chain. That's what the last name is a part of.
Yes.
But because of the priority, that's why the OL
Yes.
is at the end,
Yes,
right?
because that's right, because it has the highest priority. Alcohol has the highest priority, so it's going to be at the end. So remember, the way that we look at life, the person who has the most priority, right, is the one who gets the last name. So that's the same thing with organic compounds. The one who has the most priority gets the last name, right? You give up your last name because you're not as important as your husband, right? Or your husband isn't as important as you, so he gives up his last name, right? Okay, so that's the same thing with organic chemistry. So in this case, the alcohol is the most important, so we end with the OL, okay?
Okay.
And then because the triple bond is in the main chain, you can incorporate it into the main chain. So the main chain includes the alcohol, and it also included the triple bond.
Okay.
Okay, does that help?
Yeah, a little bit. I'm definitely just gonna need more practice. That's all.
Yeah. What was that? Yeah, and also to you guys. Yeah, yeah. No, because that's right in the middle. So you always have to start at an end, because otherwise you lose orientation. So if you're using the priority, how do you know which way to go, right? And it also makes it a lot more complicated. So the question was, yes. On the 4? Sure. Wait, I may have made a mistake. Wait, here, wait. On the 4? Wait, this 4 right here. That's 1, that's 2, that's 3, that's 4, right? All right. Do you want to put money on the? Wait, hold on. Okay, so there's a bet. We have a bet about the 4, right? Right? So what, wait a minute, hold on. What is the rule? Do we want it to have the lowest number, or do we want it to have any number? The lowest number, right? So if I count it from this side, that's 1, that's 2, that's 3, that's 4. If I count it from the other side, that's 1, that's 2, that's 3, that's 4, that's 5. So the correct answer would be okay. Was that another $5? Man, I'm gonna be rich by the time I finish with this class. I wouldn't even need a paycheck. Okay, so let's move forward. I'll give you guys the next functional group. So the next functional group is called ketones. Ketones, I'll put it up here. I'll spell it out for you. So ketones are more important than alcohols. So the prefix for ketones is oxo. Yes, ketones have higher priority than alcohols. And the suffix is all. So let's see. So the suffix is O-N-E, right? Have you guys heard of acetone? Okay. Oh, of course, I should have known. Yes, nail polish. Okay. Oh, by the way, okay, I'll tell you guys this in a second. So how many of you guys took the exam already? And you guys were really happy with your scores? Kinda? Okay. I don't want to hear it could be worse. You know, that's not what I want to hear. Okay. Of course, it could be worse. You could have got a 2, right? So that would be worse, right? So wait, hold on. Calm down. They get so excited. You guys are so excited. I can tell it gets you all worked up and happy and all stuff. Okay, so tomorrow, if you want to get some extra credit points online, we will have a Zoom link that will take you to, we're going to have a Pride event. So it'll be online at 5, wait, hold on, at 5:30. There will be a link. Wait, hold on, let me give you the details first, because otherwise, hey, you want these extra credit points or not? Okay, it's anywhere from 5 to 7 extra credit points. It depends on how I'm feeling and if you guys are interactive. If I see that you guys are interactive, I'll be more willing to give you guys that 7 extra credit points, because I know 7 extra credit points will definitely help some of your grades, because I saw some of your grades, right? I haven't finished grading everything, I'm waiting, but it could definitely help you quite a bit, okay? So if you're interactive, I will be willing to give you those 7 extra credit points. If you're not interactive and you just sit there like a brick wall, then you may get 5, and that's it, right? Like ask questions, and tomorrow at 5:30. Yes, there will be a Zoom link. It will be, I'll put a module, not a module, I will put in the top module that says events and everything, there will be a link there. And then what you need to do is, you need to take a picture of the event, like a screenshot of the event. You're going to upload that screenshot. That's going to verify that you're there. Plus, I get a list of all the students, and more than likely, my class is the only class that typically goes to things like this, because they're wanting those extra credit points. And of course, they care about Pride, right? So those are the 2 things, right? So, okay. Okay, so let's talk about, let's talk about okay. One last thing. I don't know if I told you this. I may have told you this like 20 times already, but just in case I didn't tell you, I'll tell you one more time. On the back, you actually have all of the functional groups for organic chemistry. On the back of your packet, you guys have all of the functional groups for organic chemistry. So when in doubt, you can kind of look at that. That'll kind of give you an idea of what the functional group should look like, right? And guess what? Guess what you get to use on the exam? Oh man, imagine that, right? So if you can't pass with a little help like this, I'm a little worried about you. So you need to make sure that you understand how to use it, right? Are you with me? I want to hear nodding or shaking the head, or you're just like, I'm gonna pass. I'm just gonna. What was that? You said you tried so hard? Oh, she just told me to try hard. She's like, but did she just say that? Okay. Okay, so the next thing is a ketone. can you guys help me? What do you guys think a ketone looks like? Since you guys have that packet in front of you. It looks like a graduated cylinder. Okay, so it looks like someone doing the splits. Okay, so you're saying it looks something like this. Okay, again, the R stands for any hydrocarbon or hydrogen, right? So the R's stand for any hydrocarbon. What is a hydrocarbon again? Is it a hydrated carbon? I said a hydrocarbon. Is it a hydrated carbon? Hydrated means water, right? So is a hydrocarbon does it have water in it? It does. It does not have an oxygen. It only has what? It only has hydrogen and carbon, right? So a hydrocarbon is any hydrogen and carbon, okay? Okay, so let's talk about these ketones, right? So we know that a ketone has a double bond with an oxygen. This here is one carbon. So the double bond between a carbon and an oxygen. And then it could have any functional group on the side. Okay, so the way that we would name this, you're always going to base it on the longest chain. So let me give you an example. Okay, so we're gonna count the longest chain. What is gonna be the longest chain here? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a nona, right? Okay. So we know that if we counted it from the other side, it would also be 5, right? So it's 5 either way. So then we would call this guy known, known. And then we'd say, where is it located? On the 5th carbon. So that tells me I have that double bond to an oxygen on that 5th carbon. Okay, so what was that? Yes, O-N-E, yes. Okay, what would I name this guy? Where am I going to start counting from? So we have penta. So pentone. Where is it located? It's 2-pentone. Okay. Anything else? So if it's iodine, then I do what? What do I do? Ido. Iodo. 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 Oops. Iodo. And it's 3. Okay. And then what is on that 4th carbon? Methyl. That's right. No, there's only one methyl group. We put a tri there if there was 3 methyl groups. No, the carbon, you want the longest carbon chain. That's 1, 2, 3, 4, 5. That's taken care of here, right? The 2 makes reference to where the double bond to the O is at, right? So on this main chain, you have this I, right, which is ido, and you have the methyl coming off of it on the 4th carbon. No, why would you put a tri? There's only one methyl. There's only one methyl group coming off. There's not 3. So tri would make it, there's 3 different methyl groups. That's right. It doesn't make reference to any of that. So it's only, each one has their own location. Okay? Did you guys get that? Kalinga? Fireball. Okay, you want one more, or are you guys good on this? One more. Oh, really? So, well, we have an ongoing bet, So if your guys' average is higher, then Missy Naz gets an additional $50. If Kalinga's average is higher, then Cole gets $50. If Fireball's average is higher, then so we like to keep it interesting. We want to see who's the best PA, who's the best Yes, they're like real college students. So you guys are not real college students, you're fake college students? Okay, you hear that, Kalinga? They're talking noise. Okay, so let's do this one. What is this guy? Oh yeah. can see. Yeah, and then we need the T lamps out and the lighters. They should be in there as well. It's one of these keys here. It's the one that says 3, I think. I think it's this one. Okay. Okay, so where am I going to start? I'm going to start on the left. Okay, so let's start on the left. We get a different color. Can you guys see the yellow? I can't see the yellow. Okay, is that right? Okay, so then what should be the last name? Hexone, okay. My bad. Okay. Three. Okay. So 3, and then what is the prefix for that OH? The prefix for the OH? The prefix. Hydroxy. Hydroxy, so 3-hydroxy. Oh, no, sorry, 2-hydroxy. So 2-hydroxy. Yes, that's the O-N-E, right? And then a 3 in front. Yes, we need to put a 3 in front of it. Well, this is not a double bond, right? So, and it's not attached to an O. What was it? Is it dimethyl? I have 1, 2. What about this guy? Wait, okay, that's 1 methyl, that's 2 methyls, that's 3 methyls. Trimethyl, okay? So I have to put what? What numbers? 4, 4, 4, 5, trimethyl. Oops, sorry. Okay, now it's all screwing up. Sorry, we have to start over. So let's go. It's 2-hydroxy, 4, 4, 5, tri. You guys are excitable. Hopefully it's all about chemistry, right? Three. Okay, do we have everything covered? Yes. Why am I putting a prefix on the suffix? This one? Because alcohol is lower in priority than the ketone. So you guys remember, that's, so if there wasn't, yeah, so the suffix is the guy who has the most priority. Ketone is more important than the alcohol. So then we have to use the prefix for the hydroxy, right? So let me pull up my last slide. Hold on. Okay, you guys remember this part here? I'm going to copy this and bring it over to our page so we can see it. Yeah, you will get one when I'm ready to give it to you. I have good ears. And then when I act like I don't hear you, it's because I'm ignoring you. Okay, so you guys see this? Okay, so ketone has priority over the alcohol. So since ketone has a priority of the alcohol, we have to use the alcohol's prefix instead of its suffix. A100. Do you get it? You have that look. You got it? Okay. Okay, are there questions? Okay, so right now we have ketones, we have alcohols, we have amines, we have, oh, I have amines twice. We have alkenes, alkynes, alkanes, and haloalkanes. Okay, so tomorrow I'm going to introduce 3 new ones, and then, well, 4 new ones, and then we'll call it a, we'll stop at that point because those are the ones that I want you guys to know. Okay. Okay. Questions, concerns? Yes, what you guys learn tomorrow will be on the exam. Yes, all nomenclature will be on the exam. Tomorrow, the practice exam will open up, okay? The actual exam will open up on what day? Friday through Tuesday. And wait, hold on before you guys go. After that, every Friday you will have an exam until we leave. Okay, right now, you guys have a break. You have a lab after this. Yes, sir. Yeah. Okay, I will see you guys.